Hi everyone, my name is Jeniussy Putri with NPM 234-11171 from Manajemen 23C. And now, I will talk about linear function and the applications. The first one is applications linear function. Linear functions are the simplest functions because they have only independent variable and one leaf on that variable. This function is often used in economic and business applications to explain linear economic and business relationship. It's because most economic and business problems can be translated into linear models. This application of economic and business first introduced the demand and supply function, then analyze the interaction between the demand function and the supply function in the form of market balance. Next, we will analyze changes in market balance caused by the influence of taxes and subsidies from the government. Another application is break-even analysis, which is useful for company planning. Basically, the definition of linear function is a relationship that pairs every member in set with another member in set B. All members in set A must pair with member in set B. This linear function is also called the line equation trait or PGL. As stated previously, functions in the world of mathematics are closely related to the elements that form them, namely variables, coefficients, and constants. So, a linear function is a function that forms a graph in a straight line. This linear function is also the function that has received the highest ranking with a variable equal to 1. And the second is linear function formula. The general form of a linear function is as follows: f divided x is mx plus c, or can also be fx is mx plus c, or it can be also be y is mx plus c. Information: m is gradient or slope, c is constant. Well, this linear function will not be far from graphical depiction. So when you have to do it, you have to pay attention to the following steps. The first steps is determine the intersection point with the x-axis, then y is 0. Obtain from coordinate A. 2. Determine the intersection point with the y-axis, then x0 obtained from coordinates B. 3. Connecting two points A and B will form a straight line, a linear equation, which is then writes as y is ax plus b. If b is positive, then the linear function will be drawn from the bottom left to the top right. If the b is negative, then the linear function will be drawn from the top left to the bottom right. If b is 0, then the linear function will be drawn by a line parallel to the flat x-axis. Next, there are several linear function formulas based on intersections points in a graph, namely 1. Linear function formula through one point. The linear function through one point, or xy and y1, and the gradient m can be calculated using the following formula. Y minus y1 is mx minus x1. 2. Linear function formula through 2 points. This formula is used to calculate the equation of a linear function graph from two known points, namely x1 and y1, And x2, y2, the two-point linear function formula is y minus y1, y2 minus y1 is x min x1 divided to x2 minus x1. And the last is linear function formula with gradient and axis-intercept. If it is known that the point with coordinates or 0 and b is the intersection point with the y-axis and a straight line with a slope n, then the linear function equation is y is mx plus b. There's understanding other things in linear functions. In the world of mathematics, the existence of this function can be interpreted as the relationship between one variable and another variable, each of which influence each other. This relationship also states that each member of the domain, or first member, region, has a relationship with one and only one member of the range, or second member, or branch. In this function, there are several components, namely, a variable is quantity whose value can change in a problem. Variables can be divided into two, namely independent variables and dependent variables. Independent variables are variables that explain other variables, while the dependent variable is the variable that is explained by the independent variable. Constants, namely number or numbers that form a function but are not related to a variable. Coefficients, namely numbers or figures that help form a function and are related to a variable in the functions in question. And next is example questions and discussion. The general examples are fx to x plus 1, or x is x plus 1, y is 5, or fx is 3 fx, xy is minus 4 plus 1. Linear functions have characteristics that are not far from graphic image. One example of a linear problem is in a straight line equation, namely fx is 6x and plus b. Please determine the form of this straight line equation if you get f4 is 8. So, the discussion is fx is 6x plus b. f4 is 6 times 4 plus b is 8. b is 8 minus 24. b is minus 16. So, we get the form of the linear function is fx is 4x minus 16. For further clarity, you can look at the example of the second linear function problem, namely fx is 10xb. What is the form of the straight line equation if f5 is 15? The discussion is fx is 10x plus b. f5 is 10 times 5 plus b. f5 is 10 times 5 plus b is 15. 15 is 10 times 5 plus b. We get b, the 15 minus 50 is minus 35, so b is minus 5. If you create a straight line equation, it becomes fx 10x minus 35. And here we go, the last questions. There is a linear function that is fx is 10x plus b. Determine the form of the function if it is known that f5 is 15. So, the solution is fx is 10x plus b. And then f5 is 10 f5 is 10 times 5 plus b is 15. 15 10 times 5 plus b. B 15 minus 50. B is minus 35. So fx is 10x minus 35. Thank you for listening my presentations. I hope you guys can enjoy it and have fun of it. Thank you.